So let me read back over there. So a binary ionic compound is a compound that has exactly two types of elements that are ionically bonded together. The nomenclature is simple. You just use the IDE prefix on the anion. So an example would be NaCl. That's a binary. It has exactly two elements. And the name for it would be not sodium chlorine. It would be sodium chloride. You replace the ending with IDE. A polyatomic ion is an ion that has more than one type of element. So the ions here are Na plus and Cl negative. An example of a polyatomic would be like CN. This is cyanide. All right. It has a special name for it. You don't see nitrogen, you don't see carbon in it. Another example would be like acetate. Acetate is CH 3COO negative. Has a special name for it. Then we have oxyions. Are anions, meaning negative ions, that have oxygen attached. And there's a few naming schemes. So the nomenclature for this is kind of complicated. We went over it yesterday. There's a base. So root 8. This is for when you add an additional oxygen. Then we have the root word with an 8. That's the standard amount of oxygen. Yes.
Lab some. Do you have anything planned that I need to?
I don't have anything planned, though. I have the 2 tables on the very left with stuff on them.
Okay. I have one big class of 19.
What class is that?
It's 4th period, but it's probably going to be a couple of days before I need it.
Oh, okay. I can clear out what I'm using.
Okay. That won't be a problem?
What day just did?
I don't know for sure yet, but between now and the end of the school year,
yeah, because I'm for my chemistry class, we're about to transition to almost entirely lab. Or not entirely lab, but we're going to be focused on lab. Just message me because mine's flexible. I have about 10 experiments and they're random when I can do them.
Okay, and I'm the same way.
Yeah. I've gotten all the chemicals and now I'm just going to explain to the students.
Backup scenario, I may just have to get some equipment out of here and try to do some of them in my classroom.
Yeah. Because some of mine absolutely have to use the fume hood. They're strong acids.
None of mine like that.
And I'll have to let you know because when I use one acid in particular,
we can't go in there.
Yeah, I have to shut down the whole lab for that.
Right,
because if a single drop goes anywhere on accident and someone touches it and then touches their eye, they lose the eye, they lose a finger.
Yeah.
Oh yeah, I have.
I'll get back with you to make sure.
Okay, and I usually let all the science teachers know what day that is. I only have one day where I'm going to be using this acid, and basically I try to get in touch with all the science teachers and the principal and the nurse So I'll let you know then. I don't know when I'm going to do that one, as it's very involved and it has a major cleanup.
Thank you.
Mhm. Oh yeah. Yes, I do.
Excuse me, teacher, at this time, please release the GT students and National Honor Society students to take out business while we are about the flagpole.
So the standard amount oxygen is usually 3 oxygens. 3 oxygens for most elements. Sulfur, phosphorus, and a few very uncommon ones. Their default is O4. If the root word has an ite on it, remove an oxygen. And then if we add the word hypo in front of it, then remove another one. So an example here, let's look for chlorine. Chlorine is normally Cl, or let's do something else. Let's do carbon. Carbon is usually C plus 4 or C minus 4. We can add standard is with O3 and it becomes -2, and this would be carbonate. If we add an oxygen, it becomes percarbonate. If we remove an oxygen, it becomes carbonite. And if we remove another oxygen, it becomes hypocarbonite. Now, some of these don't exist, but I'm going to show you that even though the 8 version is usually O3, something like phosphate is PO4, -3, that is phosphate. And if you add an oxygen, it becomes perphosphate. And if you remove an oxygen, it becomes phosphite. Note the ite version for this one is with a 3, and if you remove another one, it becomes hypophosphite. Usually, you only see phosphite and phosphate. You don't ever see hypophosphate or perphosphate.
If we learn about some carbon and C4. So phosphorus is the exception.
Phosphorus and sulfur are your 2 common exceptions. They all have the default one starting at 4, while almost every other one starts at 3. Another common one is chromate. And I forget the charge on it. I'm going to give y'all all some of them.
We'll be doing chloride on the
I will give you chromate. You just need to remember that if I give you chromate and then say chromite, what should you do to this?
Oh, add to it.
Ite means that you should remove one oxygen, and it should be O3.
Oh, so it's chrome ice.
Yeah. The Ite just means remove one oxygen from the standard. The standard one is the 8. We have something called multi-oxidation state ones. Four. So multi-oxidation states, this is when an element can have more than one charge. And this specifically refers to the cation versions of them. For example, iron. Iron can turn into Fe plus 2 or Fe plus 3. The naming scheme, so the nomenclature, is to write the charge after the name in parentheses in Roman numeral. So this would be called iron 2, and this would be called iron 3. And I write my 3s either like this or like this, same thing for 2s. I either connect the I's. I usually connect the I's to indicate that it is Roman numeral. And I write 1 versus 1. And if you don't know what 4 is, this is 4. And that's the largest number you'll see.
Well, if you had a L2. Right, so we're going to be going with 4, that's all 6.
Yeah, 4 is the highest number you'll see. So as long as you memorize 1, 2, 3, and 4, that's good for Roman numerals. So some examples would be rust. This is rust. Its name is iron 3 oxide. How I know this is 3 is I have to figure out what the charge is on this chemical. So I know that oxygen is -2, and I got 3 of them. So what is 3 times -2? And I have 2 iron, and to cancel out this -6, I need a +6. So 2 times what gives you +6? +3. So this +3, the 3 should go into the name right here. And I will tell you which ones have multiple oxidation states. You don't have to memorize them. For example, 10. It has multiple oxidation states. And oxidation state, or oxidation number, the same thing as ionic charge. Is this number right here. Just to confirm. All right. Let me also, so 10 can either be 10 IB, 10 4. So that'd be SN plus 4. Or it can be 10 2, or SN plus 2. So anytime you see 10, you need to have the name of it as with the Roman numerals to indicate which 10 you're using.
Need all SCCLA members to report to the front.
Oh, never mind. I got FFA after this group. Oh.
All right. Very important you write this down. Yeah. So some common polyatomic ions. Acetate. It is CH3COO negative.
What are these CO2? No, it's COO.
It's, so yes, you can sometimes write it as C2H3O2
People.
negative, but let's not use that one and use this one.
Oh.
Cyanide. By the way, cyanide is not a chemical. It's a ion. An ion is molecule with a charge.
How did you got the last last test? I don't know. I forgot.
So you should already know this one, carbonate. So carbonate is CO3 negative 2. But then we have this, bicarbonate. Bicarbonate adds a hydrogen to it and reduces, because a hydrogen is +1, the +1 and -2 make -1. This is the preferred name, though you'll never see it used, is hydrogen carbonate. Is actually the preferred name instead of bicarbonate. But bicarbonate is so used, if you go take baking soda, you'll see the name written on the ingredients list is sodium bicarbonate. The rule system for naming, the nomenclature does say you should use hydrogen instead of bi, but we never use that. Where's chromate? There it is. Chromate is one of the special ones off the ions that I didn't go over. It is also one that has 4. I don't think you'll ever see this one, but I'll just write it nonetheless. Thionate. SCN negative. And I'm leaving off the 1. Oh, ammonia. Ammonium is your only positive one, and please quit talking.
And that's the one that we talked about. Don't get confused with
ammonia. These are very important. Hydroxide. One you should memorize, OH negative. This one is very important.
I'm obviously, I have to make my. Thank you.
So let's do a few of these together.
Emmett Walker come to the office. Emmett Walker come to the office.
I thought they need to. No. No. You should get rid of the broken. I'm still. Might be a single problem. You gotta definitely. But you couldn't throw it. Yeah, that's gay.
So what? Let's do number 9.
Homosexual.
Number 9 is rubidium and nitride.
That's fine. Reveal nitride.
So what is the ion of rubidium? What charge does rubidium have? So rubidium is right here. +1. Everything in group 1 has +1. What about nitride? Nitride is right here. No. -3. So it would want to, it will gain electrons to get to 8. Remember, at carbon, it's 50-50. They'll either lose 4 or gain 4. But after nitrogen, they all lose. So they become negative. Nitride, the ide tells you it's just nitrogen with no oxygen. And it becomes -3. So to counteract this -3 charge, how many rubidium atoms do we need? 3. And just 1 nitrogen. So the formula would be Rb3n. And this first one are all binary. So all binary. So that means they're only 2 element ones. This would be the most easiest one to do. All right. So chromate is a special one that I told you what it is. Chromate is CrO4 negative. So sodium is Na plus, and chromate is CrO4, and the charge is -2. So what would the formula be?
Plus 1 would be Na. Oh wait, A. Na2 chromium.
It'd be Na2. We need 2 sodium for this -2 charge, and then it'd be CrO4.
Oh, that's for oxygen too.
Again, you treat this whole thing as being one thing. Where's your mask?
Hey, what did you put this on?
Wait,
Na2C what?
So Na2, CrO4. Oh, acetate. Acetate will also do CH3CO2. So this one, for example, what is the cation and what is the anion? The cation is the potassium and the anion is this. So what is this? Acetate. So potassium acetate.
Oh, that's not iron. No, this is FA members.
What about number 20? What would be the name of number 20?
Nitrate.
So look at number 20.
It's hydrogen.
It's
hydrogen.
What is the cation and what is the anion?
The nitrogen is the cation. The O.
So look at our common polyatomic. NH4 is ammonium. So ammonium, and whatever's left has to be the anion, and OH is hydroxide. So this is ammonium hydroxide. So this last one has to do with transition metals. Transition metals often have multiple oxidation states. It means you have to use Roman numerals in naming it. They have multiple charges.
If that looks cool, what?
Multiple oxidation states or multiple charges. So I will star which ones to use Roman numerals. Iron needs Roman numerals. Lead needs Roman numerals. Cobalt, where is cobalt? Cobalt needs use Roman numerals. Silver does not. Zinc does not. So silver is Ag plus. Actually, we can tell that silver is Ag plus because nitrate is NO3 negative, and to counteract this -1 charge, that means that Ag must be a +1. So when doing this, because silver only has one common charge, we would write silver nitrate. You don't put Roman numerals on that, but for iron, you have to put iron 2 or iron 3, like you see up here. This is iron 3, or copper. Copper could be copper 1 or copper 2. So zinc doesn't need it.
So nitrate is NO3? Okay.
Chromium does. And mercury does. So use Roman numerals on cation. So 12 and 13 do not. So don't use Roman numerals on 12 and 13. Because you can see 5 and 6, silver does not have Roman numerals, and zinc does not use Roman numerals. So let's do chromium cyanide. Or, no, let's do number 7. Iron 3 acetate. So iron 3, that is Fe plus 3. And acetate is CH3COO negative, or -1. So we have a +3 charge here, so how many acetates do we need to use?
Acetate.
Mm-hmm. So we have a +3 charge here and -1. Yeah, so what we do is we write Fe, and in parentheses, put CH3C00, and we need 3 of them, so we put a 3 right here. So this is the formula for iron 3 acetate. Not to be confused with iron 2 acetate. Yes. Mm-mm. Mm-hmm. So, any questions? Mm-mm.
I'm in the front page.
Yeah, the front page is the most easiest.
Do.
Thursday is due Thursday. You should, or maybe tomorrow at the end of class. Yeah, I think I'll let y'all finish it up tomorrow during class. Cause yeah, you have all today, all rest of the day. Y'all have 10 minutes to finish it. We work on it now, and then tomorrow. It's really not that difficult.
Oh.